Okay, class, in this lesson, you're going to learn to understand where a data value falls in relation to other values in a normal distribution. Okay, so let's go ahead and get started. So the concept that we're going to use in relation to the normal distribution is called the empirical rule, and that is that in a normal distribution, it has certain special properties, and basically what it's saying is that the approximate percentage of data values falling in any interval of the range of the data can be determined using just the mean and the standard deviation. Okay, so if we take a look at this normal distribution here on the right, okay, the top or the peak of this picture is our average, okay, and that average or mean is represented by the Greek letter mu, okay, that looks like this letter U. And what we see also is the standard deviation, which is the spread or the distance away from the average. Okay, so if this area or this point here is the average, then the first standard deviation is right over here, this blue line here. Okay, and we would call this one standard deviation or one distance away from the average. And the empirical rule says that 68% of the population would fall in this first standard deviation. Then the next deviation would be two standard deviation, and this would cover 95% of the population. And then if we go out to 3 standard deviations, so 1, 2, 3, okay, on both sides of the normal curve, this would cover 99.7% of the population. Okay, and standard deviation is also denoted by the Greek letter sigma, which looks like this right here. Okay, so again, mu is the mean, and then sigma is the standard deviation. So this would be 1 standard deviation away, 2 standard deviation away, and then 3 standard deviation away. And then these are the respective percentages. Okay, so as I've summarized over here, okay, how far from the mean does a value in a normal distribution fall? So about 68% of all values fall within 1 standard deviation. So this is the range that I was referring to. And then 95%, or about 95% of all values fall within 2 standard deviations. So that's in this range. And then about 99.7% of all values fall within 3 standard deviation. Okay, so let's go ahead and move forward and take a look at this example number 1. So in this example, we're looking for population intervals, and basically it says that a study of chest circumference among a group of Scottish men exhibited an approximately normal distribution. Okay, their chest circumferences range from 33 to 48 inches with a mean or average chest measurement of 40 inches. And it has a standard deviation of 2 inches. So the question here is, what range of chest measurements contains the 68% which fall closest to the mean? Okay, so what we're going to do here is draw a normal distribution curve. And it would look something like this. Okay, and we would say that, let me go ahead and shift this over just a little bit. We would say then that the mean would fall right here at the very center and at the peak. And we're told that the average measurement, chest measurement, is 40 inches. Okay, so we would go ahead and notate this as 40 inches, and we're told that standard deviation is 2 inches. Okay, so we're going to move in intervals of 2 inches. Let's see, so this will be 42, 44, 46, and then we're going to move 2 standard deviation in the opposite direction. This will be 38, 36, and 34. Okay, now we are here to determine what range of chest measurement contained 68%. Well, based on the earlier example, we know that the first standard deviation would be from about here, about 38 to 42, okay, and we know that approximately 68% fall in this range. Okay, so the range of chest measurements would then be from 38 to 42 inches. Okay, so 38 to 42 inches. Okay, and then part B asks what we would expect the chest measurements to be for the 2.5% of the men with the smallest chest measurements in the population. Okay, so we know that if we went out to 2 standard deviations from the mean, so there'd be 1, 2, as well as 1, 2 in this direction. Okay, so if we included this, all of this, then we know that this area would be 95%. Okay, that means that since this whole area is 95% of the population, then we know that the balance, so this side here and this side here, would equal 5%. And since there are 2 sides to this, we can say that the balance here is going to be 2.5%, and then this side is 2.5%. Okay, and since we are looking to see what we would expect the chest measurements to be for the 2.5% of the men with the smallest chest measurement, then we would expect that the men's chest circumference of the lowest 2.5% would be on this side. So then the chest measurement would be 36 inches or less. Okay. All right, so let's go ahead and move on to example 2. All right, so we're told that in a recent SAT scores for college-bound seniors are normally distributed with a mean score of 508 and a standard deviation of 121. So the question here is, what proportion of students received scores between 387 and 629? Okay, so what proportion of the students? So let's go ahead and draw a normal curve again. All right, and we have a standard normal curve here, and let's say that this is our average. Okay, and our average score was 508, and we are told that the standard deviation is 121. Okay, so if we went out to 1 standard deviation, 121 plus 508 would be 629. And if we went out 1 standard deviation to the left of 121, we subtract 121 from 508, this would give us 387. Okay, so this area under this curve represents 68%. Okay, and the question here is, what proportion of students receive scores between these 2 ranges? Then the answer is 68%. Okay? And then part B asks, what proportion of students receive scores greater than 387? Well, we know that since this is 68%, then the balance, so this side and this side, would be 22%. Okay? Because 100 minus 68 is 32, not 22, 32%. Okay? So if the balance is 32%, that would suggest then that this side is 16% and this side is 16%, because that would give us a total of 100%. And we want to know what proportion of students receive scores greater than 387. So we would say that it's this 68% plus the 16%, because scores greater than 387 would be everything to the right of 387. Okay, so then we would say that it would be 68 plus 16%. Okay, so that would be 84%. So 84% of the students received scores greater than 387. Okay, so let's take a look at example 3. Now we're going to take into consideration the z-score. Okay, and z-scores are typically used when we are dealing with values that don't fall nicely within 1, 2, or 3 standard deviation. Okay, so in this example, we have Ella and Alicia, and they're comparing scores on their college entrance exams. So Ella takes the SATs and scores a 1380, and Alicia takes the ACT and scores a 32. Okay, and we're told that the mean SAT score is 1,000 with a standard deviation of 200, and the mean ACT score is 21 with a standard deviation of 5. Okay, and the question here is, who has the better score? Okay, so if we think about this, Ella scored 1380. Okay, and we know that the mean SAT score is 1,000 with a standard deviation of 200. So we're not going to be able to land on 1380 evenly because the standard deviation is 200. So our intervals are going to be 1,000, 1,200, and 1,400. Okay, which isn't quite 1380. And same thing is also true with the ACT. We're told that the ACT score has an average of 21 with a standard deviation of 5. So that means our intervals are going to be 21, 26, 31, 36. Okay, and it doesn't quite land on the 32 for Alicia's ACT score. So we're going to use the z-score, and the z-score formula, z-score is equal to the average, the data value that we're looking at minus the average or the mean divided by the standard deviation. So in calculating the z-score for the SAT, okay, so our z is going to equal, when we talk about the data value, we're going to look at Ella's SAT score, so it's 1380, minus the average of 1,000 divided by the standard deviation of 200. Okay, and this works out to 380 over 200, which is equal to 38 over 200, over 20, which is the same thing as 19 over 10, which works out to 1.9. Okay, so that gives us a z-score of 1.9. So let's take a look at the one for ACT. So using the same z-score formula, we're going to take the actual data value, which is 21. Not 21. Alicia scored 32. Okay, I'm going to say z is equal to 32 minus the average, which is 21, divided by 5. And that works out to 11 divided by 5, which means my z is 2.2. Okay, so since 2.2 is greater than 1.9, this means that Alicia had the better score. Okay, all right, so let's go ahead and move on to our last example, example 4. Okay, so we're going to use a z-score to compute percentage. So in this example, we have the weight of captive adult female lowland gorillas, and it's normally distributed with a mean of 82.30 kilograms and a standard deviation of 15.33 kilograms. So we need to calculate the z-score for Sasha, whose weight is 61.8 kilograms. Okay, so let's go ahead and calculate the z-score for Sasha. Okay, Sasha weighs 61.8 kilograms, and we're going to subtract the mean, which is 82.3, and we're going to divide that by the standard deviation of 15.33. And if we punch this into the calculator, the z value works out to negative 1.34. Okay, so now when you have a z-score and we want to look at the percentage, we would use the standard normal distribution. And the standard normal distribution has an average of 0 and a standard deviation of 1. Okay, so this is our standard normal distribution. And if we wanted to know where negative 1.34 falls, that lands us right about here. So it's about negative 1.34. Okay, so that would represent that area. So if we were to use this score to find the percentage of captive adult female lowland gorillas whose weights are less than or equal to Sasha, okay, less than or equal to Sasha, we would want to find the area of this curve, okay, the area under this curve. All right, so there are a couple ways to do this. One, we could do some calculations that would take quite a while to get our answers, or we can use the power of a spreadsheet to calculate this. Now, depending on the type of spreadsheet that you use, the steps are a little bit different, but here I'm going to use Apple's numbers spreadsheet. And the way you do this is you're going to go ahead and punch in equals, and I'm going to type in norm. I'm looking for a normal S distribution, okay, and we see that this is the third selection here. And then we're going to punch in the z value that we calculated. That was negative 1.34. And hit return, and it's going to give us a number of 0.09, okay, 0.0901. So let's to the problem, and we're going to take 0.0904 and multiply this by 100 because we want to go to a percentage, and this will give us a 9.04%. Okay, so this is the percent of captive adult female lowland gorillas whose weights are less than or equal to Sasha's. Okay, hopefully this made sense. If it didn't, please go back to the beginning of the recording and listen to this again. Thank you.